Hello friend, in the last video we have discussed about the IUPAC nomenclature of ketone. In this way we have completed the nomenclature of aldehyde and ketone. Now we are going to discuss the preparation methods of aldehyde and ketones. The preparation methods, it is the reaction that used to prepare the aldehyde and ketone, the synthesis of the aldehyde and ketone. There are several methods to prepare aldehyde and ketone. We are discussing today the first important method to prepare aldehyde and both ketones, that is from the oxidation of alcohol. The first and important method to prepare aldehyde and ketone from alcohol. What is by alcohol? We know that the hydroxy derivative of hydrocarbon, that means the compound that contains OH group, hydroxy group in their structure, that is called as alcohol. And our method is the preparation of aldehyde and ketone from that alcohol, therefore by using the method of oxidation. Here the alcohol undergoes oxidation reaction. We know that what is oxidation? The reaction in which the addition of oxygen takes place from the oxidizing agent, the reaction called as oxidation. Here alcohol undergoes oxidation. It means the addition of oxygen atom takes place in the structure of alcohol, and alcohol converted to aldehyde and ketone respectively. Now, first of all, in this reaction the oxidizing agent is used because this is the oxidation reaction, and each and every oxidation reaction, the oxidizing agent which can be used. Here we use the acidified potassium dichromate solution, the oxidizing agent. That is the mixture of K2Cr2O7 plus dilute H2SO4. Here H2SO4 is present, dilute H2SO4 is present. Therefore, this potassium dichromate is called as acidified potassium dichromate, which acts as a good oxidizing agent in this reaction. Now, firstly, we are going to prepare aldehyde. It means the reaction for the preparation of aldehyde. Preparation of aldehyde from alcohol by using oxidation method. Here, if you want to prepare aldehyde from alcohol, here the primary alcohol we require firstly, because when primary alcohol undergoes oxidation, primary alcohol when undergoes oxidation by using this K2Cr2O7 plus dilute H2SO4, it is acidified potassium dichromate. This primary alcohol converted to corresponding aldehyde. So we know that what is primary alcohol? It is the type of alcohol in which the OH functional group of alcohol which is attached to the primary carbon, therefore it is called as primary alcohol. The reaction for the preparation, that is general reaction for the preparation of this aldehyde from this primary alcohol, because when primary alcohol undergoes oxidation using K2Cr2O7 dilute H2O4, it is converted to respective aldehyde. So therefore, what is the general formula of primary alcohol? That is RCH2OH. Primary alcohol always written as RCH2OH because CH2OH, that CH2OH is the group of the primary alcohol. Every primary alcohol contains CH2OH group in their structure. Therefore, this primary alcohol, when oxidizes by using the mixture of K2Cr2O7 plus dilute H2SO4, it means when primary alcohol undergoes oxidation by using acidified potassium dichromate, or directly we can say that mixture of K2Cr2O7 plus H2SO4. After all some heating, the nascent oxygen produced in the reaction, this oxygen atom, that nascent oxygen atom which require for oxidation, coming from the reaction when it takes place in between K2Cr2O7 and H2SO4, that oxygen atom get added with this structure. It means here if we can write this hydrogen as this hydrogen this hydrogen and this oxygen, this two hydrogen and this oxygen, when combined, it gives H2O. It means removal of water molecule takes place in the form of byproduct in the reaction. What is remaining? RCHO. This two hydrogen, this oxygen gives H2. Remaining RCHO. So RCHO, we know that we can write as RC double bond OH. Here is the formation of aldehydes takes place in this way. This is the general reaction. How to memorize the reaction? The reaction in which when primary alcohol undergoes oxidation by using acidified potassium dichromate, it means the mixture of K2Cr2O7 plus dilute H2SO4 reaction gives corresponding aldehyde. What about the example? Example first, if you want to prepare formaldehyde, it means formaldehyde preparation in which when methyl alcohol, we know that what is methyl alcohol? That is CH3OH is the methyl alcohol. It is the primary alcohol because it contains CH2OH group in the structure. When this methyl alcohol again reacted as like the general reaction, that is mixture of K2Cr2O7 plus dilute H2SO4. The reaction gives, after addition of this oxygen, the reaction gives that formation of H2O takes place as like the general reaction, and remaining is CH2O. We can write as that is CH2. Here is CH2O. Here is CH2O like that double bond O. Yes, C double bond OH is the structure of formaldehyde. The structure of formaldehyde. So, how to prepare formaldehyde from methyl alcohol? When methyl alcohol undergoes oxidation by using acidified potassium dichromate, that is mixture of K2Cr2O7 and dilute H2SO4, the methyl alcohol undergoes oxidation and converted to corresponding formaldehyde with formation of water as a byproduct. But important note for this reaction is, if we use the K2Cr2O7 and dilute H2SO4 as an oxidizing agent, here we accept the formaldehyde is the last product, but that is not. In this reaction, this formaldehyde again automatically undergoes oxidation in same reaction. What happened firstly? When methyl alcohol oxidized by using K2Cr2O7 and dilute H2SO4, reaction firstly gives formaldehyde. Here expectation is that the reaction stop at the stage of formaldehyde and the last product is formaldehyde. But the reaction cannot stop at the stage of formaldehyde. Here formaldehyde again undergoes oxidation in the same reaction, in the same oxidizing agent. That is, when this oxygen added in the formaldehyde structure, again we obtain here SC double bond O, and due to this oxygen, here is the OH, SCOOH. The last product is not the formaldehyde, but it is formic acid. Here, by using K2Cr2O7 H2SO4 from methyl alcohol, we cannot directly prepare formaldehyde only, but formaldehyde form and it is converted to formic acid. If you want to stop, the important note for the reaction is, if you want to stop the reaction of methyl alcohol at the stage of formaldehyde, then you want to take the option of oxidizing agent, that is PCC. The full form is pyridinium chlorochromate. which is the mild oxidizing agent. Pyridinium chlorochromate is a mild oxidizing agent. If we use the PCC as the oxidizing agent instead of K2Cr2O7H2SO4, the reaction stop at the stage of only formaldehyde. There is no further oxidation of formaldehyde into formic acid. What about the reaction? When methyl alcohol undergoes oxidation by using the K2Cr2O7 dilute H2SO4, not only formaldehyde forming the reaction, but formaldehyde further oxidizes into formic acid. Formaldehyde is the not last product. Formic acid is the last product. If you want formaldehyde only, if you don't want formic acid, then take the another option of oxidizing agent. That short form is PCC. And what is the long form of PCC? That is pyridinium chlorochromate. That can stop the reaction at the stage of only aldehyde. That means in this case at the stage of formaldehyde. Formaldehyde not further oxidizes into formic acid. That the another example for the preparation of acetaldehyde. Then for preparation of acetaldehyde from that respective alcohol, the reaction as like this is the CS3CH2OH. We know that. What is CS3CH2OH? This is the ethyl alcohol. Another example of primary alcohol, which is also undergoes oxidation by using acidified K2Cr2O7 and dilute H2SO4, and like the previous reaction. Here in this reaction again a nascent oxygen atom which is added because this is the oxidation reaction. So due to this oxygen, if two hydrogen atoms and this oxygen combines to produce H2O, what is remaining? CS3CHO. How to write CS3CHO? CS3C double bond OH. This is the structure of acetaldehyde. If you use only a K2Cr2O7 H2SO4, then reaction cannot stop at the stage of acetaldehyde. Further, acetaldehyde oxidizes in the same reaction, in the same oxidizing agent into CS3COOH. Due to addition of oxygen, one oxygen here, the formula converted to CS3COOH. This is the structure of acetic acid. And you know that if you want to prevent the formation of acid, the option for this oxidizing agent is PCC. That is pyridinium chlorochromate. That pyridinium chlorochromate add instead of K2Cr2O7H2SO4 in the reaction stop at the stage of only acetaldehyde. There is no formation of acetic acid. That about the preparation of the aldehyde from the oxidation of primary alcohol. Now memorize the reaction. How to prepare the aldehyde from the oxidation of primary alcohol? When primary alcohol undergoes oxidation by using acidified potassium dichromate, primary alcohol converted to respective aldehyde. Now we are going to discuss the reaction of preparation for ketone. How to prepare ketones from this method? From oxidation of alcohol, because this oxidation of alcohol can be prepared aldehyde, can be prepared ketone also. But if you want to prepare ketone from this method, here you want to take the starting material as a secondary alcohol. For aldehyde, we take the primary alcohol, and for ketone, the oxidation of which product is takes place. The oxidation of secondary alcohol takes place, and secondary alcohol converted to respective ketones. For example, the general reaction is RCH ROH. RCH. That secondary carbon attached with OH. Therefore, this type of structure is called as secondary alcohol. So, secondary alcohol that contain OH group are attached to the secondary carbon. Why this secondary carbon? Because this carbon attached with to another carbon. Therefore, it is secondary carbon. And secondary carbon if contain OH group, that is secondary alcohol. So that secondary alcohol always contain CHOH group. CHOH group. We know that primary contains CH2OH, but secondary contains CHOH group. So therefore, this secondary alcohol, when undergoes oxidation by using same acidified potassium dichromate solution, like the aldehyde. Here again oxygen atom is added in the reaction. This one hydrogen, this another hydrogen, that two hydrogen, oxygen combines to give another H2O molecule, as like the general previous reaction, similar as aldehyde. And what is remaining here? If these two hydrogens are withdrawn from the structure with this oxygen and combine to form H2, what is remaining in the reaction? RCOR. So what is RCOR? Just like this RC double bond OR. We know that this is the general structure of ketone. Similar as aldehyde, in this reaction also, ketone oxidizes into carboxylic acid. If you take this oxidizing agent, acidified potassium dichromate, to stop the formation of acid after the formation of ketone, similarly, here also the option of oxidizing agent, that is pyridinium chlorochromate. So instead of K2Cr2O7 dilute H2SO4, if you take PCC, the reaction stop at the stage of only ketone. So memorize here how to prepare a ketone from secondary alcohol. When secondary alcohol oxidized by K2Cr2O7 and dilute H2SO4, reaction use firstly ketone to avoid the formation of carboxylic acid at the PCC in this reaction also. For example, if you want to prepare acetone, that is dimethyl ketone, acetone also known as dimethyl ketone. You have to the raw material or starting material of isopropyl alcohol like this. CS3 CHOS CS3, that is isopropyl alcohol, or it is also called as secondary propyl alcohol. So when isopropyl alcohol or secondary propyl alcohol undergoes oxidation by using K2Cr2O7 plus dilute H2SO4, the nascent oxygen atom is added in the reaction from the oxidizing agent. Here, these two hydrogen and this oxygen is combined to give H2O. What is remaining? CS3COCS3. So CS3COCS3 is CS3C double bond OCS3. So what is CS3C double bond OCS3? This is the structure of acetone, also called as dimethyl ketone, in IUPAC called as propanone. So similarly, this reaction cannot stop at the stage of acetone when we use only K2Cr2O7 H2SO4. Then another oxygen atom is added in the same reaction. But this oxidation is not easier as aldehyde. In this oxidation, this carbon-carbon bond also break, And here we get firstly CS3COOH. For balancing of the reaction, here some CO2 molecule and H2O molecules are formed. So how many CO2 and how many H2O form? One CO2 and one H2O form, because if you take 4 oxygen atom is here. So in this reaction, when isopropyl alcohol oxidizes by using acidified potassium dichromate, reaction firstly use acetone as a product, first product, but reaction cannot stop at this stage. Reaction further undergoes oxidation, but this oxidation not easier as like the oxidation of aldehyde into carboxylic acid. This is the drastic oxidation in which 4 nascent oxygen atoms get added. Here acetone converted to acetic acid. How the acetic acid is formed? The breaking of this carbon-carbon bond also takes place. So therefore here CS3COOH, 1 oxygen from these 4 oxygen atoms, H from the remaining 3 hydrogen of CS3. Therefore CS3COOH. 1 carbon, 2 oxygen, CO2. That 2 and 1, 3 oxygen. What is how many remaining oxygen atom? Only 1. That 1 oxygen and remaining 2 hydrogen, that is H2. That about the preparation of the acetone from the isopropyl alcohol. If you want to stop the reaction at the stage of only acetone, so instead of K2Cr2O7 dilute H2O super, take the another option of oxidizing agent, that is PCC. If you write PCC on the arrow, instead of K2Cr2O7 H2O super, only write the product as acetone, because reaction stop at this stage. That about the first method of preparation of aldehyde and ketone from the oxidation of alcohol by using acidified potassium dichromate.